PLT, OTC, perform horizontal situation configuration per your checklist.
OTC, PLT, that's work. And CDR, or OTC, CDR, BFS, for Ops 1, those steps are complete.
Copy, sir. And CDR configured. Continuously abort yaw steering per your checklist.
CDR, what?
NTD, CDFS. Go ahead. Ready for BFS uplink. And Houston Flight NTD, perform BFS pre-flight uplink loading.
Copy, we'll put it in work.
Thanks.
The OTC CDR yaw steer is checked, enabled. It's complete.
Copy, sir.
And we're at T-minus 15 minutes and counting. The closer crew is basically packing up their stuff into their van to head back off the pad. Mike Mangione, former closeout crew member, what did they do before they left?
Okay, they made after they broke the white room down, they made sure that they had everything that they had taken out was accounted for. They stow it in the elevator. Crew waves to the flight crew. This is the last time they're going to see them before they come back. Down the elevator they go. They unload the elevator and they stow everything in their vehicles. There are 2 vehicles waiting at the bottom of the pad for them. When everything is accounted for, they clear it with the OTC and then they exit the pad. They're heading back to the fallback area and they're going to stand by. If it launches, it's a beautiful view. If it's a scrub, if they have to go back in for any reason, they're standing by just in case.
Well, I'm going to go with it's going to be a beautiful view. How's that?
Absolutely.
All right, Mike Mangione, thank you very much for joining us and helping us walk through as the closeout crew closed out Space Shuttle Discovery for its STS-124 mission. And at T-minus 13 minutes and 45 seconds, this is Shuttle Launch Control.
OTC, CDR, horizontal SID config on path and BFS are complete.
Copy. And PLT, perform NPS helium reconfiguration.
And OTC, that's at work. OTC, PLT, MPS helium reconfig is complete.
Copy, PLT. And MPS OTC, can you give me 1053, please?
MPS, verifies 53.
Thank you.
NTD Launch Director 212. Yes, sir, go ahead. Yes, sir, I'd like you to set up for the Pane 1 in-plane launch time today, please. Certainly, we'll do that.
NTD Houston.
MS5.
CPD and FCP OTC.
Is APD? FCP.
Adjust the fuel cell loads to between 250 and 290 amps.
Copy and work. Flight NTD, did you call?
That's firm. I can give you 1049 VFS pre-flight. Uplink load is complete.
Copy that. And CVFS, you copy? Copy that.
OTC CDR?
Yes, sir. Go ahead.
Yeah, ICOM voice check is complete. It's all good.
Copy. And all systems discontinue all non-LDB traffic for the remainder of count.
OTC CDR?
Go ahead, sir.
Yeah, we're back at 14.7 on the bottom of 1-8. Just standing by to close the vent valve.
Copy. And ECL OTC?
Detail.
We're standing by for step 941, sir.
Copy that. We're close.
Thank you.
This is shuttle launch control at T-minus 9 minutes and 15 seconds. Just 15 seconds, we'll be going into the last built-in hold of the countdown, T-minus 9 minutes.
Countdown clocks at T-minus 9 minutes and holding. Duration of hold will be 45 minutes and 12 seconds.
We are now in the T-minus 9 minute hold. Lasts for another 45 minutes.
NTD safety on 212.
Go ahead.
Did we get step 948?
That's the firm we did.
Do you have a time on that?
15:53.
Thank you.
NTD CVFS.
Go, sir.
1082. T-minus 20 minute GPC dump complete. 0 miscompares. NTD copies.
Flight controllers are not working any issues that would prevent us from launching on time at 5:02 p.m. Eastern. And once Discovery clears the launch tower, command and control of the STS-124 mission switches to Mission Control Center in Houston, NASA's Johnson Space Center. And at this time, we're going to go there for an update from Public Affairs Officer Rob Navius.
NTD, I'll give you 1086 for the depletion sensor.
Copy.
Okay, we'll use this.
This is Mission Control Houston at T-minus 9 minutes and holding. Flight controllers belonging to the Ascent team have been on console since 10 o'clock today, monitoring Discovery systems in preparation for its launch to deliver the giant Kibo Science Laboratory to the International Space Station for Japan. The Ascent team is led by Flight Director Norm Knight, with the help of astronaut Terry Virts, who is the spacecraft communicator, or Capcom. Virts will be talking directly to the crew during Discovery's 8.5-minute ride to orbit. He's joined on console by astronaut Kevin Ford, who is monitoring weather conditions at the Kennedy Space Center. Ford is in direct contact with Chief Astronaut Steve Lindsay, who's flying the shuttle training aircraft around the vicinity of the shuttle landing strip at the Cape. Lindsay is assessing the weather in the event Discovery has to perform a return to launch site abort. At the time of Discovery's launch, the International Space Station will be orbiting 210 miles above the Atlantic, southeast of Halifax, Nova Scotia. The launch is timed to match the moment when the Earth's rotation carries Launch Pad 39A into the corridor or plane of the station's orbit. We continue to target the preferred in-plane launch time of 4:02:12 p.m. Central Time, 5:02 and 12 seconds p.m. Eastern Time, for a Flight Day 3 rendezvous with the International Space Station. Down the hall from the shuttle flight control room, another team of flight controllers is on duty in the International Space Station flight control room, led by Flight Director Chris Edelin, as they watch over the activities of the Expedition 17 crew aboard the International Space Station. Commander Sergei Volkov and Flight Engineer Oleg Kononenko are in their 54th day in space since their launch April 8th in a Soyuz rocket from the Baikonur Cosmodrome in Kazakhstan. They arrived on the station on April 10th to begin their half-year on the complex. NASA astronaut and flight engineer Garret Reisman was delivered to the station on the last shuttle flight in March. Today is Reisman's 82nd day in space, his 80th day on the outpost. Shuttle flight controllers here in Houston are watching weather conditions at the overseas abort sites in Spain and France, which would be used in the event of an engine failure early in Discovery's climb to orbit. Morón, Spain is considered the prime transoceanic abort site today for Discovery and its crew. Histris, France is also available today if necessary. At launch, Discovery will be sent aloft on the collective power of its 3 liquid fuel main engines and its twin solid rocket boosters, combining for a total of 7 million pounds of thrust. 30 seconds into the flight following the roll maneuver, the computers will throttle the main engines down to 72% of rated performance, designed to lessen the aerodynamic forces on the shuttle's fuel tank and the orbiter's aero surfaces. Those engines will throttle back up to 104% of capability about 40 seconds later. Shortly after solid rocket booster separation, Discovery's orbital maneuvering system engines will ignite for 2 minutes 15 seconds, providing an assist for the shuttle as it heads uphill. A little less than 6 minutes into the flight, the onboard computers will command the main engines to swivel, allowing Discovery to roll to a heads-up position above its fuel tank, enabling the shuttle to gain more favorable communications with the tracking and data relay satellite system. About 8.5 minutes after launch, the main engines will be commanded to shut off and the shuttle will separate from its external fuel tank. Discovery will settle into an elliptical orbit around 135 statute miles above the Earth at its apogee, which will be refined to a higher elliptical orbit above the Earth 45 minutes into the flight through a firing of the shuttle's orbital maneuvering system engines. Additional rendezvous maneuvers will be executed over the course of the next 2 days, bringing Discovery to a docking with the International Space Station on Monday afternoon. Seconds after discarding the fuel tank, Commander Mark Kelly will maneuver Discovery so that video and digital cameras in the shuttle's umbilical well can capture imagery of the tank as it falls away. Mission Specialist Karen Nyberg will operate a video camera, and Mike Fossum will use a digital still camera to capture handheld imagery of the fuel tank for downlink and analysis by imagery teams here in Mission Control. That will take place with Discovery some 1,450 feet from the tank. Discovery 7 crew members will go to work shortly after the shuttle's payload bay doors are open, activating systems, unstowing gear, and preparing for their first 8-hour sleep period in orbit, which will begin just after 10 p.m. Central Time. Again, the ascent team and Flight Director Norm Knight are set to take over control of the 35th flight of Fleet Leader Discovery and the 123rd mission in shuttle program history at solid rocket booster ignition. At T-minus 9 minutes and holding, this is Mission Control Houston.
We have another 38 minutes and 30 seconds remaining in this last built-in hold in the countdown. During this time, the shuttle launch director, Mike Leinbach.
Okay, we did get from security over on 232, step 932, that our personnel are clear of the LDA.
And safety copied, we can give you 1063.
Copy, thank you.
The NASA launch director, the NASA test director, Jeff Spaulding, and the mission management team, which is the program group responsible for overall mission, will do their go, no-go polling. And we also can hear obviously the checklist of things going. At this time, flight controllers, launch controllers rather, are not tracking any issues. that would prevent us from launching on time at 5:02 p.m. Eastern.
SRO NTD on 212. SRO. KSC area is clear for launch. SRO copies.
At T-minus 9 minutes and holding, this is Shuttle Launch Control.
Houston flight NTD.
NTD Houston flight.
Any changes to our launch window times or our lock streamback times?
No changes in the past G1 launch target uplink and BFS G1 launch target uplink are not required today.
Okay, copy all. Thanks. NTD STM. Go ahead. 1077 complete. Copy, thanks. And it's the NTD. I'll go ahead and give everybody our final launch times. OTC, TBC, PTC, LPS, MILA, STM, Safety, SPE, LRD, SRO, CDR, and GLS. Our final launch window opening, based on our preferred time, is 21:02:12 GMT, and it will close at 21:08:59 GMT, and it does consist of 2 panes. Our lock strain back hold time, based on our preferred time, is 4 minutes and 07 seconds, and that is based on performance. OTC, you copy?
OTC copy.
TBC?
TBC copies.
PTC?
PTC copies.
LPS?
LPS copies.
MILA?
MILA copies.
STM?
STM copies.
Safety console?
Safety console copies.
SPE?
SPE copies.
LRD?
LRD copies.
SRO?
SRO copies.
CDR?
CDR copies.
And GLS?
GLS copies.
And GLS, we'd like to go ahead and set the countdown clock to resume at 20:53:12 GMT.
GLS copies, and that's complete.
Thank you.
This is Shuttle Launch Control at T-minus 9 minutes and holding. We have 32 minutes and 35 seconds remaining in this last built-in hold for Space Shuttle Discovery's STS-124 mission.
For all personnel, have 32 minutes, 30 seconds of hold time remaining.
You're looking at firing room 4
GOIS NTD on 212.
in the Launch Control Center, which is about 3 miles from the launch pad.
Yes, GOIS. This is GOIS. Go ahead. Yeah, just looking for a status on your cameras. Are you ready to support launch?
Yes, all of our cameras are ready to support launch. Are you ready for the fill-ins?
I am.
Long range north, 8. Long range south, 8. Medium range north, 6. Medium range south, 6. Medium range west, 6. And the short range are 6.
Okay. NTD.
There are about 180 people in the firing room that you're looking at. And there are lots more people in rooms supporting this room, around 470 or so, who are supporting this launch today.
And Launch Director NTD, our ground camera system is verified and ready to support launch. Copy, thank you.
The Launch Control Center is the place that, since the Apollo days, human spaceflight has been, launch at least of human spaceflight has been controlled. And in firing room 4, there's also a senior management on the Space Shuttle and Space Operations side for NASA. And the mission management team members, as I mentioned earlier. They'll be conducting their go, no-go polling.
SPE, NTD on 212.
PC, sir.
Yeah, I'm still showing just one open constraint. Do you know how we're doing on getting that one closed?
Yes, sir. We reviewed the closure here already, and we're up getting off the constraint switch right now.
Excellent, thanks.
You're welcome.
There's 30 minutes remaining in this last built-in hold. And right now, no issues are being worked, including the weather, that would prevent us from lifting off on time at 5:02 p.m. At T-minus 9 minutes in holding, this is Shuttle Launch Control.
OTC, CFCP.
Go ahead.
Yeah, if possible, if EPD could get our loads up a little higher. We're floating right below 23 kilowatts. We need to be above that.
EPD, OTC.
EPD copies. We can add something to a main A. That's all we've got. OTC, CMPS.
Go NPS.
Yes, step 1114. Completion sensors, SIM command removal, final checkout complete.
Copy.
NTD copies.
CLHY and CLUX copy.
CLX copies. CLHY copies.
This is Shuttle Launch Control at T-minus 9 minutes and holding. We're just under 25 minutes left in this last built-in hold, as we methodically go down the checklist and work our way towards a launch at 5:02 p.m. Eastern. Flight controllers are not working any issues that would keep us from launching on time today. Shuttle Discovery's STS-124 mission has been described by the Space Shuttle Program Manager, John Shannon, as a milestone mission. On one hand, this is the external fuel tank that Discovery is going to use today as the first tank built from the ground up with all the post-Columbia accident safety improvements. All previous tanks have been modified to incorporate the safety enhancements, and this tank was built with them from the ground up. This is also the 10th mission since we started resuming flights. You see this graphic, we're looking at two of the modifications made on the, actually there were a total of 11 modifications made on this particular tank that were built right in. Two of them, however, and gaining the most attention. They redesigned the liquid hydrogen tank and the ice frost ramps in 14 different locations. And the ice frost ramps are structures that are made of foam insulation that cover brackets on the outside of the shuttle's external fuel tank. Those ramps have been cited as a potential source of foam loss, which of course could come off and damage the shuttle. So we redesigned the liquid oxygen feed line brackets in 4 locations, and those feed line support brackets are made of titanium, which require less foam, and it makes it less likely that ice will form on there as well, which can be a debris source. Although these tanks will look pretty much the same, the modifications will be visible when we take our imagery of the tank after it separates, and of course on launch itself. Well, taking a look at Discovery on the pad there, inside its payload bay. It's a slightly different configuration than we've had since returning to flight back in 2005. You can see the main cargo, the Japanese experiment module, pressurized module, the JPM, and the Japanese remote manipulator system, the robotic arm.
OTC CDR.
Go ahead, CDR.
A couple of us would like to pump up our suits.
You have a concurrence to do that.
Copy, thank you.
You'd also see in that graphic the shuttle robotic arm, but what was missing was the orbiter boom sensor system, which is actually awaiting Discovery. Up on the station, it was dropped off during the last shuttle mission in March. Of course, the Japanese pressurized module is the main cargo for this flight, and the main purpose of going up there is to install it. I'll take a minute now to get a little closer look at that particular laboratory.
The Japanese experiment module is named Kibo, meaning hope. Kibo is actually made up of 5 major
And for all
segments delivered to
personnel,
the
we have
International Space Station over the course of 3 Space Shuttle missions. The diverse elements making up Kibo will allow the space station crew to conduct experiments both inside in microgravity and outside in the direct exposure to space. The larger of the 2 pressurized modules will serve as the working laboratory. A smaller pressurized logistics module that sits atop the laboratory will be used primarily for storage of tools and supplies. On the outside are 2 more segments, the exposed facility to hold experiments and a logistics platform. The final piece is a robotic arm attached to the laboratory. The arm will allow astronauts inside the lab to access external facilities and experiments. Attached to the space station's Harmony module, the arrival of Kibo greatly expands the scientific work of the orbiting outpost.
And as we looked at that video, the logistics module that was mentioned is in a temporary position on board on the station right now, dropped off during the last shuttle flight. It's on the Harmony node, and it will be moved to its permanent position on the pressurized module during Discovery's 14-day mission. The outside storage facility and research facility that will be the final major components of Kibo.
Is C-Prep. Yeah, just wondering how your pressures are looking now. After we did the pre-plan, I know we were in pretty good shape. Just want to see how your trends are.
Yes, they're looking real good, Jim.
Okay, and we should be
Nice
good.
and flat here.
Okay, should be no other issues or pre-plans required to the remainder account, correct?
But nothing from us, sir.
Great.
That exterior facility will go up on a shuttle flight next year, the STS-127. And that will bring up all the major elements and complete assembly of the Kibo laboratory. Once the STS-124 mission is complete and Discovery departs, the International Space Station will be about 71% complete by mass or weight if you're on the ground here. Total station weigh around 612,000 pounds. The International Space Station program here is described the work after the STS-124 mission. After Discovery departs, the Space Station crew, Expedition 17, will begin major preparations for expanding the crew size from its current complement of 3 people to a 6-person crew next spring.
CLT OTC.
Go ahead.
Clear hardware, caution, and warning memory.
Copy, inward.
DVD OTC.
What's DVD?
Can you verify step 1119?
I can verify that, and step 1116 is not performed.
Copy.
OTC PLT, hardware caution warning memory is complete. It's cleared.
Copy.
We have about 13 minutes and 30 seconds remaining in this last built-in hold in Space Shuttle Discovery's STS-124 launch countdown. When we do resume the count at the T-minus 9-minute mark, the ground launch sequencer will be in control of all critical operations, and this master computer will issue all of the commands necessary to perform the final critical tasks required to put the spacecraft in final launch configuration. The ground launch sequencer monitors about 1,000 different critical shuttle functions during the final 9 minutes of the count. Make sure they don't fall out of our normal limits. Coming up on the final polling in the firing room. Make sure that everything is on track and everybody concurs and agrees with going forward with the launch. Just at this particular moment, though, there are not working any issues that would prevent us from launching on time at 5:02 p.m. Eastern. At T-minus 9 minutes in holding, this is Shuttle Launch Control.
HCD OTC. Can you verify step 1139?
And for all personnel, we have 10 minutes of hold time remaining here at T-minus 9 minutes. We're tracking no constraints. CISL, JRPS, and Houston flight. Perform the L-15 recorder activation, ISL. ISL copies. JRPS.
JRPS copies.
And Houston flight.
Houston flight copies. We'll put it in work.
MS1 OTC.
Good.
Activate V10 recorder.
That's in work.
This is Shuttle Launch Control at T-minus 9 minutes and holding. We have about 5 minutes and 15 seconds remaining in this last built-in hold. In the next minute and a half or so, be conducting the final go, no-go poll from inside firing room 4 at the Launch Control Center here at NASA's Kennedy Space Center. And I guess I can provide sort of a preview. Things are looking pretty good. And
now, this is the NTD conducting the launch status check. Verify ready to resume count and go for launch. OTC?
OTC go.
TBC? TBC's go. PTC?
PTC is go.
LPS?
LPS go.
Houston flight?
Houston flight is go.
Mila?
Milo's go.
STM?
STM is go.
Safety console?
Safety consoles go.
SPE? SP is go. LRD? LRD's go. SRO?
SRO is go. You have range clear to launch.
And CDR?
CDR's go.
And Launch Director NTD, our launch team is ready to proceed at this time.
Okay, copy that, Jeff. Thanks. Chief Processing Engineer, verify no constraints to launch. And Mike, the engineering team is ready to go. Okay, thank you, Charlie. KC Safety Mission Assurance. KC and Safety Mission Assurance is go, Mike. Thank you, Mark. Payload Launch Manager. Space Station team's ready to go, Mike. Good, thanks, Bill. Range Weather.
Weather has no constraints for launch.
Very good, Kathy. And Ops Manager. Let's see, Launch Director, Ops Manager on 212. Mike, E.M.E.T. is not working any issues. You are go to launch. Okay, thanks, Leroy. Discovery Launch Director.
Go ahead.
Okay, Mark, it's a gorgeous day to launch, so on behalf of the KSC launch and processing teams, I'd like to wish you good luck, Godspeed, as you deliver the next piece of Kibo to the International Space Station.
Hey, thanks, Jeff. You're right. We're going to deliver Kibo or Hope to the space station. And while we all tend to live for today, the discovery from Kibo will certainly offer hope for tomorrow. Minasan arigato, ite kimasu. Now stand by for the greatest show on Earth.
Thank you, sir. NTD, with that, you are clear to launch Discovery.
Copy that. Thank you, sir.
And we have been given the go to launch on time at 5:02 p.m. Eastern.
For all personnel, our countdown clock will resume in 2 minutes, 30 seconds.
to the ISL.
Go ISL.
Recorders are activated.
I copy. Countdown clock will resume in 1 minute.
This is Shuttle Launch Control at T-minus 9 minutes in holding. We're just about to come out of the 9-minute hold.
3, 2, 1, mark.
T-minus 9 minutes and counting.
GLS auto sequence has been initiated.
And we are less than 9 minutes away from launching of Space Shuttle Discovery. The ground launch sequencer has been initiated. And everything remains on track for a on-time launch at 5:02 and 12 seconds.
PLT, OTC, connect essential buses to fuel cells per your checklist.
OTC, PLT, that's one. OTC, PLT, essential buses are connected to fuel cells.
Copy.
This pilot Ken Ham switching the 3 fuel cells on board Discovery.
GLS is go for orbiter access arm retract.
Discovery, OTC, best of luck delivering the GM module to the International Space Station.
Discovery copies. Thank you, Teresa.
T-minus 7 minutes and counting. The go has been given to retract the orbiter access arm. This is the walkway that the crew uses to get inside and outside of Discovery. And if the need arose, we could move it back into position within a few seconds.
CRPS, start APU display recorders.
Recorders are running.
PLT, perform APU pre-start.
And that's in work.
T-minus 6 minutes and counting. You can see this wider shot of the accessway being moved aside.
OTC, PLT, APU pre-start is complete with 3 great talkbacks.
Copy.
Pilot Ken Ham now is at the auxiliary power units. 5 minutes, 30 seconds and counting. T-minus 5 minutes and counting.
TLS is go for orbiter APU start.
PLT, perform APU start.
And OTC from PLT, that should work.
CDR, reconfigure heaters.
Heater reconfig, in work. OTC CDR, heater reconfig complete.
Copy.
T-minus 4 minutes and 30 seconds.
OTC PLT, APU start is complete.
Copy.
T-minus 4 minutes and counting.
TLS is go for purge sequence 4.
Final test of the flight control surfaces being done with a pre-programmed pattern of movements designed to verify the engines and other flight surfaces are ready. That includes moving the 3-min engines, and that's how Discovery steers its way in orbit. T-minus 3 minutes and counting.
TLS is go for ET LO2 pressurization.
PLT, clear caution and warning memory, verify no unexpected errors.
OTC, that should work.
Top of the external fuel tank, known as the beanie cabin, being removed at this time.
PLT, caution and warning memory clear is complete with no unexpected errors.
Copy. Discovery, close and lock your visors and initiate O2 flow.
Discovery and work.
T-minus 1 minute, 58 seconds and counting.
TLS is go for ET LH2 pressurization.
T-minus 1 minute, 30 seconds to launch. Everything remains on track. T-minus 1 minute and counting to the launch of Space Shuttle Discovery. T-minus 50 seconds. Transferring the shuttle's internal power now. It's running on its onboard 3 fuel cells. Coming up on go for auto sequence start. The computers on board Discovery control the spacecraft.
CLS go for auto sequence start.
25.
T-minus 25 seconds and counting.
20.
T-minus 15 seconds and counting.
10.
10 seconds. We have go for main engine start. 7, 6, 5, 4, 3, 2, 1. Booster ignition and liftoff of Shuttle Discovery. Combate Kudasai. Best of luck to the International Space Station's newest laboratory.
Houston, Discovery, roll program.
Roger, roll, Discovery.
Houston now controlling the flight of Discovery, a man-made rising sun on behalf of Japan. Discovery on the proper alignment, heads down, wings level for the 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Space Station. "36 seconds into the flight, the 3 liquid fuel main engines now throttling back to 72% of rated performance, going in the bucket, reducing the stress on the shuttle as it goes supersonic. Discovery already 5 miles in altitude, 8.5 miles downrange, traveling almost 1,000 miles an hour.
Discovery Houston, go at throttle up.
Roger, go at throttle up.
Throttle up call acknowledged by Commander Mark Kelly, joined on the flight deck by pilot Ken Ham, flight engineer Ron Garan, and mission specialist Karen Nyberg. Down on the middeck are Mike Fossum, Aki Hoshide, and Greg Chamitoff, heading for a half year on the International Space Station. One minute, 45 seconds into the flight. Discovery 22 miles in altitude, 23 miles downrange, standing by for solid rocket booster separation.
Copy staging.
Booster officer confirms staging, a good solid rocket booster separation. Guidance now converging. The onboard computer steering the shuttle for the on-ramp to the highway for the International Space Station. Discovery 37 miles in altitude, 50 miles downrange, traveling 3,200 miles an hour. The orbital maneuvering system engines have ignited, providing Discovery with a burst of power for the next 2 minutes, 15 seconds.
Roger, 2-engine Marone.
That call from Mark Kelly, the first of a series of performance calls in the event of the loss of a main engine. However, all 3 main engines continue to perform normally, along with the auxiliary power units and the 3 power-producing fuel cells. Discovery flying on the singular power of its 3 liquid fuel main engines, draining 1/2 ton of fuel per second from the large fuel tank. Discovery 52 miles in altitude, 100 miles downrange, 3.5 minutes into the flight. We're coming up on the point of negative return, where the shuttle would be too far downrange, too high in altitude to return to the launch site in the event of an engine failure. All 3 main engines continue to function normally, however. 3 minutes, 47 seconds into the flight. Discovery flying straight and true, speeding toward a date with the International Space Station on Monday.
Discovery Houston, negative return.
Roger, negative return.
All of Discovery's systems in great shape. 4 minutes, 15 seconds into the flight. Discovery 62 miles in altitude, picking up speed, 170 miles downrange, traveling 5,300 miles an hour. The Environmental Systems Officer reports the activation of the flash evaporator system, providing cooling for Discovery's avionics and other systems until the time that the payload bay doors are open an hour and a half into the flight. 4 minutes, 40 seconds into the mission. All the main engines right down the money, in good shape, good performance, good auxiliary power units, good fuel cells. Discovery traveling 6,000 miles an hour, 66 miles in altitude, 230 miles downrange from the Kennedy Space Center. Five minutes into the flight, 3.5 minutes of powered flight remaining. Very quiet here in the flight control room.
Discovery Houston, press to ATO, select Istris.
Roger, press to ATO, we'll select Istris.
That call acknowledged by Commander Mark Kelly, indicating that in the event of a loss of a main engine, we could still make our abort to orbit targets. However, all three main engines continue to function normally. The orbiter will soon begin to roll to a heads-up position. Now beginning that roll to heads up, the main engine's now swiveling. The shuttle rolling to its position above the fuel tank, gaining more favorable communications to the tracking and data relay satellite system as it heads uphill. 6 minutes, 15 seconds into the flight, Discovery traveling almost 10,000 miles an hour, 397 miles downrange from the Kennedy Space Center.
Istris 104, your shutdown plan is nominal, and your go for the +X, go for the pitch.
Copy that, Terry. Copy the boundary. Nominal shutdown plan. Go for the +X. Go for the pitch.
Good readback, and you are pressed to MECO.
Roger. Press to MECO.
Press to main engine cutoff call by Commander Mark Kelly, indicating should we lose a main engine, we can still make our nominal main engine cutoff targets. However, all three main engines hang in perfectly, as well as the auxiliary power units and the fuel cells at the 7-minute mark into the flight. Discovery now 515 miles downrange from the Kennedy Space Center, traveling 11,000 miles an hour. Very soon, the main engines will once again be throttled down to limit the stress on the shuttle and its 7 crew members to that of 3 times the effective gravity.
Houston, single engine press 104.
Roger. Single engine press 104.
At the time of main engine cutoff, a little more than a minute from now, Discovery will enter its preliminary orbit at a speed of 5 miles a second. Discovery 615 miles downrange from the Kennedy Space Center, looking great. Engines now throttling back. Less than a minute of powered flight remaining for Discovery. Traveling 14,000 miles an hour, almost 700 miles downrange from the Kennedy Space Center. Discovery passing 23,000 feet per second at the 8-minute mark into the flight. A flawless ascent so far for the orbiter. Standing by for main engine cutoff. That'll be followed a few seconds later by the separation of the external fuel tank. Booster officer confirms main engine cutoff, standing by for external tank separation. External tank separation confirmed. Discovery now in its preliminary orbit. The centerpiece of Japanese space science, Kibo, completing the first leg of its journey to the International Space Station. Commander Mark Kelly will now maneuver Discovery to the correct orientation so that video and digital stills of the fuel tank can be captured by cameras embedded in the shuttle's umbilical well for post-flight analysis.
Discovery Houston, that was a nominal MECO. OMS 1 is not required.
Copy, nominal MECO, OMS 1 not required.
A short time from now, Mike Fossum will unstrap from his seat down on the middeck. We'll float up to the flight deck to join Garan Nyberg to take handheld video and digital stills of the external tank as it maneuvers away from Discovery. A perfect ascent, a perfect on-time launch for Discovery. The 14-day mission now underway to deliver the Kibo module to the International Space Station. Greg Chamitoff now on his way to replace Garret Reisman to begin a half year on the complex. This is Mission Control Houston. NASA television now originating from the Johnson Space Center here in the Shuttle Flight Control Room, where the ascent team of flight controllers, which has been on duty since 10 o'clock this morning, overseeing the perfect ascent of Discovery and its arrival on orbit. The crew now beginning the initial phase of its post-insertion activities. The first item of business is the photography, both with a video camera and a digital still camera by Garan Nyberg and Mike Fossum of the external fuel tank. That video to be downlinked about 5 hours into the flight so that imagery experts here in Mission Control can have an opportunity to begin their analysis of how the tank performed. Here in the flight control room, Flight Director Norm Knight, joined on console by Flight Director Richard Jones, who supervised the weather analysis throughout the course of the countdown today. The spacecraft communicator Terry Virts, joined by astronaut Kevin Ford, who
your go-to-work checklist as written through 3-7. For SA, your OMS 2 TIG, it'll be 3717. Do not load that. We'll take the one that's in the onboard targets. It's for SA only.
Okay, copy 3717, and we'll work the checklist through 3-7.
Good read back. Tail-only control is not required, and welcome to space, guys.
Hey, thanks a lot, Terry. It's good to be back, and it's good for everybody to be here.
Commander Mark Kelly, now beginning his third flight into space after 2 stints as a shuttle pilot on STS-108 and STS-121. Again, Terry Virts, the spacecraft communicator, joined on console on the far left of your screen.
APU hide shutdown.
Copy that, Terry. Thanks.
Kevin Ford managed the weather in concert with discussions with Chief Astronaut Steve Lindsay, who was flying the shuttle training aircraft around the vicinity of the Kennedy Space Center during the pre-launch time frame, receiving real-time weather updates. Today was mostly a no-brainer for weather at the Kennedy Space Center, an almost pristine day weather-wise. 2 good transoceanic abort sites. Everything fell in line technically and mechanically. Discovery launching on time at 4:02 p.m. Central Time, 5:02 Eastern Time, arriving on orbit 8.5 minutes later. Pilot Ken Ham will now begin the procedures to shut down the 3 auxiliary power units as countdown clocks here in Mission Control tick backward toward the first firing of the orbital maneuvering system engine since Discovery's arrival on orbit. That so-called OMS 2 burn scheduled 23 minutes from now, a fairly large firing of the orbital maneuvering system engines that will raise the apogee of the orbit of Discovery and move it from a highly elliptical orbit into a more circular orbit. Once again, the first of basically the series of rendezvous maneuvers was the launch itself, as the International Space Station was traveling 210 miles southeast of Halifax, Nova Scotia at the time of Discovery's liftoff. The two-day chase now for Discovery to catch up to the International Space Station on Monday, culminating with a docking on Monday afternoon just before 1 p.m. Central Time. Following the firing of the orbital maneuvering system engines, the crew will get busy preparing to open the payload bay doors and to deploy the heat dissipating radiators that will take over the job of cooling the avionics on board Discovery that is currently in the hands of the flash evaporator system on board the orbiter. We're now ready to return to the Kennedy Space Center for a variety of launch replays from the battery of cameras at the launch site in Central Florida. We'll continue to monitor operations and the developments in the early stage of Discovery's 2-week mission. Let's go back to the Kennedy Space Center now for the launch replays.
Discovery going to Ops 105.
Copy that. We're following along.
And Houston, Discovery, if you're ready, we can load targets.
We like the onboard TIG. You're going to load and maneuver, and we are 20 seconds from spreading.
This is Mission Control Houston. You're watching a series of replays from the Kennedy Space Center of today's launch of the Shuttle Discovery and its 7 crew members. The launch occurring just 18 minutes ago. Discovery systems in good shape. The crew beginning the early stages of its post-insertion checklist, setting up shop for the ride to the International Space Station and a docking on Monday. The ensuing 9 days of joint docked operations with the International Space Station crew. On board the space station, Commander Sergei Volkov and flight engineers Oleg Kononenko and Garret Reisman watched the launch of Discovery on a television feed that was uplinked to them. So Reisman fully aware that his replacement, Greg Chamitoff, is on his way now to begin the handover operations that will highlight part of the 9 days of joint docked operations once Discovery arrives at the complex. As we continue to watch the replays of Discovery's launch, the booster officer here in Mission Control reports that the dump of the remaining fuel in the main propulsion system of Discovery has been complete. Everything looking good on board the orbiter. Countdown clocks ticking backwards to the ignition of the orbital maneuvering system engines 15.5 minutes from now. A fairly substantial OMS 2 burn that will further refine Discovery's apogee, turn it from a highly elliptical orbit into a more circular orbit as it begins its chase to catch up to and dock with the International Space Station Monday afternoon. The mechanical systems officer reports that the external tank doors on the belly of the orbiter are in the process of closing per the procedures. As Discovery passes high over Europe, preparing for the firing of the orbital maneuvering system engines and the first of its rendezvous burns, the OMS 2 burn, to further refine its orbit. The International Space Station moving from northwest to southeast at an altitude of about 210 statute miles, currently flying over the United Arab Emirates.
Houston, Discovery.
Go ahead, Discovery.
Yeah, we're through with through page 3-7, and we'd like to put block 3 of post insertion app station config in work.
Okay, copy that. Discovery Houston with some words for the burn and also block 3.
Ready to copy.
First of all, if you could, as you're working through block 3, just hold off on the handheld microphone until after the burn, just to make sure our comm is good for the burn. Second issue, during ascent, we saw the left ohms secondary gimbal. It looks like a power fail, so we're going to treat the left ohm secondaries as failed. So if you have a primary failure or the main A or FF1 or FA1A, things that takes down the primary gimbal, we'll treat that as a second gimbal failure on the left.
Okay, copy that. And if you're ready, we're going to maneuver.
We're ready for the maneuver.
This is Mission Control Houston. That call from spacecraft communicator Terry Virts to Commander Mark Kelly on board Discovery. There was an indication from the booster officer during Discovery's climb to orbit that a secondary set of electronics that operates the gimbling function or the swiveling function for the left orbital maneuvering system engine failed. However, the primary system of electronics remains up and running and in good shape. No impact to any operations as we stand by for the firing of the orbital maneuvering system engines just 10 minutes from now. In the meantime, Discovery is currently maneuvering to the burn attitude. This will be a firing of both orbital maneuvering system engines, a rather long burn of 2 minutes and 44 seconds in duration. Coming up on the 30-minute mark into the flight of Discovery as we continue to watch launch replays from the Kennedy Space Center. Again, Discovery in good shape with the exception of a minor issue with a secondary left orbital maneuvering system gimbal electrical circuit that was detected to have a problem during Discovery's climb to orbit. This has no impact on any operations as we stand by for the firing of those orbital maneuvering system engines 7.5 minutes from now. There are 2 electrical paths to provide the swiveling or gimbling capability for those orbital maneuvering system engines so they can be positioned properly when they fire for major maneuvers during any shuttle flight into space. The primary gimbal electrical system for the left orbital maneuvering system engine continues to be in good shape with no issues. Continuing to watch launch replays from the Kennedy Space Center as we approach the 5-minute mark to the firing of the orbital maneuvering system engines. Again, this will be a rather long burn of 2 minutes and 44 seconds because of the short phasing angle, the orbital mechanics that the flight dynamics officer interpolates for the flight control team here in Mission Control. This burn will further circularize Discovery's orbit and refine its path to the International Space Station, one of several maneuvers that will place Discovery on its course for a docking to the station just before 1 p.m. Central Time on Monday. The propulsion officer here in Mission Control reports a good helium configuration for the orbital maneuvering system engines as we approach the 3.5-minute mark to the firing of both OMS engines, the large engines that flank the vertical tail fin at the rear of the orbiter used for major maneuvers in orbit by the shuttle. Here in Mission Control, the Guidance, Navigation, and Control Officer reports that Discovery is in the proper orientation relative to the Earth for the upcoming firing of the Orbital Maneuvering System engines. The electrical problem detected with the secondary gimbal or swiveling actuator system for the left Orbital Maneuvering System engine has no impact on this mission.
Discovery Houston, you're in a good config for the burn.
Roger, good config for the burn.
This is Mission Control Houston. The propulsion officer reports that the firing of the Orbital Maneuvering System engines is underway. This again will be a 2-minute 44-second firing of both OMS engines in a large maneuver to circularize Discovery's orbit and refine its path to the International Space Station.
Discovery, that was a good burn, no trim required.
Discovery copies, thanks.
And Discovery, with some words on your ohms, the primaries look good on the left. For the post-burn gimbal check when you get there, do not do the check on the secondaries on the left. You can only do primary on the left. and both primary and secondary on the right.
Okay, Terry, we copy all. Thank you.
The completion of the orbital maneuvering system burn, a good burn of 2 minutes and 44 seconds to place Discovery at an orbit currently of 196 by 170 statute miles.
First switch.
Go ahead.
Yeah, Terry, we're doing block 2. It's on ML 86 Bravo Road Charlie, and inadvertently closed, and a main Bravo external airlock heater struck Z123 instead of the required main Alpha. Do we ever go to swap those?
Thanks for the heads up, and you do have a go to swap those. And Discovery.
Done, thanks.
Okay, and while I have you for post-insertion, you can finish up block 3 now.
And Houston Discovery, we copy. One quick question on the gimbal check. On the left, do you prefer to do primary twice?
That's far, Mark. We'll take it twice.
That didn't work.
That discussion between Capcom Terry Virts and Commander Mark Kelly on board Discovery, the post insertion procedures to check the orbital maneuvering system engines. The crew instructed not to perform a check on the secondary gimbal system or swiveling system of the left orbital maneuvering system engine that incurred an apparent electrical failure during Discovery's climb to orbit. This has no impact on the mission. Engineers and mission managers will evaluate that over the course of the next several days. The primary system is in excellent shape. There's no correlation between the electrical systems for the primary and secondary gimbal actuators, as they are known. Those two electrical systems are isolated from one another to prevent any commonality of a failure that could incur. So with Discovery safely in orbit, now at the 43-minute mark into the mission, the crew is in its post-insertion checklist. About 45 minutes from now, we expect the crew to begin the procedures to open up the payload bay doors. Karen Nyberg and Ron Garan, who was the flight engineer for today's ascent to orbit, sitting directly behind Commander Mark Kelly and pilot Ken Ham, and next to mission specialist Karen Nyberg. Garan and Nyberg will be responsible for overseeing the opening of the payload bay doors, the deployment of the radiators, and then the shutdown of the flash evaporator system that is currently providing cooling for Discovery's avionics. Here in Mission Control, Flight Director Norm Knight discussing with the Guidance Navigation and Control Officer the best way to manage the left orbital maneuvering system engine. There's no rush to come up with a solution or a course of action. The primary gimbling or swiveling capability of that orbital maneuvering system engine is just fine. There is no impact to the mission at this point. Nor is one expected. The left orbital maneuvering system engine has a perfectly clean primary gimbling electrical system. It was the secondary system, the backup system, if you will, that incurred an apparent electrical failure during Discovery's climb to orbit. The orbital maneuvering system engines will be used for major maneuvers during the course of Discovery's 14-day mission, 9 days of which will be docked to the International Space Station. The OMS engines are, of course, used in tandem for the deorbit burn at the end of the mission to enable Discovery to reduce its velocity and drop out of orbit for the hour-long descent back to the landing strip at the Kennedy Space Center. Continuing to watch replays of Discovery's climb to orbit that occurred on time at 4:02 and 12 seconds p.m. Central Time, 5:02:12 Eastern Time.
And Houston Discovery, we're ready for Ops 106.
We're ready. We are ready for that, Discovery.
Okay, that's complete, Terry, and we are going to go to post-insertion.
Copy that. We're following along.
Houston Discovery, count check on the handheld mic.
Got you loud and clear, Discovery.
Yeah, we got you loud and clear as well.